Hello friends, most welcome to my YouTube channel Maths by Samit Deshmukh. So today we are going to prove the properties of what? Inverse trigonometric function. See, in the last video we have discussed the definition of inverse function, inverse trigonometric function. Even using graph we have seen or we have tried to understand its domain and what? Range. Now let us begin with the first important properties. Properties are nothing but what? Formulas for us. So this inverse trigonometric function is also used in differentiation also and in integration also. You have seen the derivatives of inverse trigonometric function and integration of inverse trigonometric function. Means the result which we are going to prove here can also be used in differentiation and integration, even in another chapter also. So let us prove the first property. In this case we have to prove that value of sine inverse of x will be equals to cosec inverse of 1 by x. So now here x where x lies in between what? -1 to +1. We know that domain of sine inverse is what? In between -1 to +1. So let us try to prove this property. So now here I am considering right hand side and I am denoting this right hand side by say y. So let cosec inverse of 1 by x will be equals to y. Means y is nothing but value of what? Cosec inverse of x. Means definitely this y takes the values in which in its range. And what is the range here? So therefore we can say that y belongs to what? Minus pi by 2 to plus pi by 2, difference 0. Isn't it? If y is the value, y is nothing but value of what? Cosec inverse of x. Cosec inverse means definitely this value lies in its range, and the values which lies in the range and satisfies the given inverse trigonometric function is called as what? Principal value. This definition already we have discussed in the last video. So therefore now if we are taking cosec on both sides, so on this side cosec of cosec inverse of 1 by x will be equals to what? 1 by x, and if we are taking cosec on right hand side we will get cosec y. So which property we have applied here? We know one property, that cosec of cosec inverse of x will be equals to what? X. So this property also we have discussed in the last video. So here just simply taking cosec on both sides. If we are taking cosec on left hand side, on this side we will get 1 by x and on this side we will get cosec y. Now this can be written as, just we are trying to convert this result in terms of what? Sine, because our left hand side is sine inverse. So we are taking reciprocal of both sides. What is the reciprocal of left hand side? Will be equals to, what is reciprocal of 1 by x? Will be x, and reciprocal of cosec y will be equals to what? Sine y. Just simply we have taken reciprocal on both sides. So therefore now we are taking sine inverse on both sides. On this side we will get sine inverse of x, and on this side sine inverse of sine y will be equals to what? Y. And y belongs to what? Y already belongs to what? Minus pi by 2 to plus pi by 2, difference 0. And can I say that this is nothing but subset of what? Minus pi by 2 and plus pi by 2, because here y is nothing but value of what? Sine inverse of x. Y is nothing but value of what here? Sine inverse of x. If y is the value of sine inverse of x, means y should take the values in between what? Minus pi by 2 to plus pi by 2. But according to this supposition, y lies in this interval, and this interval is nothing but part of what? Minus pi by 2 to plus pi by 2. Means this is subset of minus pi by 2 to plus pi by 2. That's why such values can be considered as principal values, or here y lies in what? Range of sine inverse. So therefore keep left hand side as it is, sine inverse of x as it is, and y is nothing but what? Cosec inverse of what? 1 by x. In this way we have proved that sine inverse of x is equal to cosec inverse of 1 by x. So even note that, write down this as a note, even we are able to prove that cosec inverse of x is equal to what? Sine inverse of 1 by x. So this result also we are able to prove using same method. So this is one of the first very important property. Now let us try to solve the second important property. In this case, we have to show that value of cos inverse of x will be equals to sec inverse of 1 by x. So I am supposing that sec inverse of 1 by x is equal to y. So let sec inverse of 1 by x will be equals to y. So this implies that y belongs to, now y is nothing but value of sec inverse, means it will lies in which interval? Its value lies in between 0 to pi, difference pi by 2. Okay, so therefore if we are taking sec on both sides, so on this side if we are taking sec and sec inverse will get cancelled, remaining term is 1 by x, and on this side if we are taking sec, on this side we will get sec y. Now taking reciprocal of both sides, what is reciprocal of left hand side? X, and what is reciprocal of sec y is equal to what? Cos y. So therefore taking cos inverse on both sides, so on this side we will get cos inverse of x, and on this side cos inverse of cos y will be equals to what? Y. And now this y is nothing but value of what? Cos inverse of x, means it should belongs to which interval? It should belongs to which interval? 0 to pi, means y is value of what? Cos inverse, so it should belongs to that range set, means in between 0 to pi. Now only the remaining part is to check whether this value lies in that interval or does not lies in that interval. Here already we have got which result? Y belongs to 0 to pi, difference what? Pi by 2, and this is nothing but part of which this is nothing but subset of what? 0 to pi. This whole set lies in this interval, or this whole part lies in this interval. That's why we can say that it is subset, means value of y belongs to this set. That's why we can say that it is a principal value, or it lies in the range of cos inverse. So therefore cos inverse of x will be equals to y. But what is y? Y means what? Sec inverse of 1 by x, and this is the result which we have to prove here. In the same way, we are able to prove that sec inverse of x will be equals to cos inverse of 1 by x. Whatever may be the method we have applied here to prove this property, same method can be applied to prove this second property also. But this proof of this property is not given in our textbook, but remember that this property we have to use while solving the examples. Now see the third property. In the third property, when x is greater than 0, at that time we have to show that value of tan inverse of x is equal to cot inverse of 1 by x. Here also we are applying same method. So let us suppose that here, let y is equals to, or cot inverse of 1 by x is equals to, cot inverse of 1 by x is equals to y. If y is the value of cot inverse of x, means definitely it lies in which interval? 0 to pi. So implies that y belongs to what? 0 to pi. So this is our supposition. We have denoted cot inverse of 1 by x is equal to y. If this is the value of cot inverse, means definitely it will lie in between what? Which interval? 0 to pi. Now if we are taking cot on both sides, so on this side cot of cot inverse of 1 by x will be equals to 1 by x, and on this side we will get cot y. Simply we have taken cot on both sides. Now we are taking reciprocal of both sides. What is reciprocal of 1 by x? Will be equals to x. Since we have taken reciprocal of left hand side, so take the reciprocal of right hand side. What is the reciprocal of cot y? Will be equals to what? Tan y. So here it is given to us that since x is what? X is what is given condition? X is greater than 0. If x is greater than 0, then it implies that greater than 0 means value of x is what? Positive. X is nothing but value of what? Tan y. As it stand, y lies in between what? 0 to pi, means it lies in this interval 0 to 2 pi, means in first quadrant or in second quadrant, means value of y lies in first two quadrant. Now if x is positive, means tan y is positive, but we know that value of tan y is negative in which quadrant? In second quadrant value of tan y is what? Negative. So that's why we are not able to consider second quadrant, because in second quadrant this condition is not satisfying. X is what here? Positive, means tan y is positive, but in second quadrant tan y is what? Negative. So that's why we can say that y belongs to what? Only in first quadrant. Only in first quadrant means in between 0 to what? Pi by 2. Means here this condition is satisfying for this inverse trigonometric function, but x is given to us that it is positive. That's why we can say that value of tan y lie only in what? First quadrant, because this condition is satisfying only in first quadrant. So now, therefore, taking tan on this side or taking tan inverse on both sides. So on this side we will get tan inverse of x, and on this side if we are taking tan inverse, tan will get cancelled according to our property. So on this side remaining term is what? Y. Now y is nothing but value of what? Tan inverse of x. So it should belongs to what? Its range. What is the range of tan inverse? Minus pi by 2 to plus pi by 2. But already we have proved that y belongs to what? 0 to pi by 2, and 0 to pi by 2 is nothing but what? Subset of what? Minus pi by 2 to plus pi by 2. So this is nothing but subset of this part. 0 to pi by 2 means first quadrant, and minus pi by 2 to plus pi by 2. This 0 to minus pi by 2 means here it will be fourth quadrant. This angle is negative, means rotation is in what? Clockwise direction. And 0 to pi by 2 means what? First quadrant. Means minus pi by 2 to plus pi by 2 means first and what? Fourth quadrant. So here this first quadrant is the part of what? Fourth and first quadrant, means this interval is subset of this interval. So that's why we can say that this value of y belongs to our range. So we are able to consider it as value of what? Tan inverse. So already we have proved that y is value of tan inverse, so it should belongs to what? Its range. And here we have proved that this value of y belongs to its range. So tan inverse of x, keep it as it is. Y we are replacing by its value cot inverse of 1 by x, and this completes the proof. Now let us try to prove the second part. In the second part, what is the given condition? X is greater than 0. Let us see what we'll get if x is greater than 0. Again we are repeating the same method here. So let us suppose that value of cot inverse of 1 by x will be equals to y. Then again it implies that y will belongs to what? 0 to pi. Now taking cot on both sides, so on this side cot and cot inverse will get cancelled, we will get 1 by x. On this side we will get cot inverse of y. So taking reciprocal on both sides, we have taken cot on both sides. Reciprocal of left hand side is x. What is reciprocal of cot y? Will be equals to what? Tan y. Now here it is given to us that x is less than 0. So since x is what? Less than 0. It is given condition that x is less than 0. If x is less than 0, then we have to check that y lies in which quadrant. As it stands, y lies in what? 0 to pi means first and second quadrant, but here value of x is negative. X is negative means tan is negative, but in first quadrant tan is what? Positive. So here this condition is satisfied only if tan lies in what? Second quadrant. Means here we can say that y belongs to which interval? Second quadrant. Second quadrant means y lies in between. Y is greater than 90 degree, means pi by 2, and less than 180 degree, means y lies in which quadrant? Second quadrant. So taking tan on this side, so it will become tan inverse of x, means taking tan on this side means simply we have taken tan inverse on both sides. On this side we will get tan inverse of x, and on this side tan inverse of tan y will be equals to what? Y. Now y is the value of what? Tan inverse. If it is the value of tan inverse, means it should belongs to what? Its range. Its range is in between what? Minus pi by 2 to plus pi by 2. Minus pi by 2 to plus pi by 2 means which two quadrant? First and fourth quadrant. But here y lies in which quadrant? Second quadrant, means our condition is not satisfying. Y belongs to second quadrant, but range of tan inverse is first and what? fourth quadrant. So y does not belongs to range, so that's why we are not able to consider this as a value of what? Y. That's why we are simplifying it. So to simplify it, just simply we are subtracting pi from each term. Just simply subtract pi. What we'll get if we are subtracting pi here? So pi by 2 minus pi. Keep inequality as it is. Pi minus y minus pi is less than what? Pi minus pi. Just we are subtracting pi from each term. If we are subtracting same value from each term, inequality does not changes. So now pi by 2 minus pi will be equals to what? Minus pi by 2. Keep this y minus pi as it is, less than pi minus pi will be equals to 0. Now y minus pi lies in between what? 0 to minus pi by 2. 0 to minus pi by 2, and this 0 to minus pi by 2 belongs to what? Range of what? Tan inverse. So that's why we are able to consider y minus pi as its principal value. So now here we are simplifying it. Before shifting it on this side, let us simplify it. X, keep it as it is, which is equals to, now can I write it as tan, here y minus pi is there, okay, so here can I write this term as pi minus y? What is the value of tan pi minus theta? Will be minus tan theta. So minus is not there, so I am writing minus here. Now after simplifying it, let us check whether we are getting same term or not. What is the value of tan pi minus y? Will be minus tan y. Minus and this minus will become plus tan y. Means plus tan y can be expressed in this form. So which is equals to minus, keep it as it is, tan also as it is. Now simply I am taking minus common from both the term. If we are taking minus common, so negative term will become positive term will become what? Negative. Just simply we have taken minus common from these two terms. Now this term is in the form of tan minus theta. What is the value of tan minus theta? Will be equals to minus tan theta. So minus, keep it as it is, tan also as it is, its value will be equals to minus tan theta. So minus tan theta, theta is what here? Y minus pi. So here minus and minus will become plus. So what result we have got here? X will be equals to tan y minus pi. Now we are taking tan inverse on both sides. Let us see what we'll get if we are taking tan inverse on both sides. So on this side we will get tan inverse of x, tan inverse of x. And if we are taking tan inverse on this side, tan and tan inverse will get cancelled. What will get? Y minus pi. So tan inverse of x, keep it as it is. So this y also as it is, minus pi. Y we are replacing by its value. What is the value of y? Y is nothing but cot inverse of 1 by x. So replace this y by what? Cot inverse of 1 by x. Keep this minus pi as it is and check whether we have got our required result or not. So in this way we have got our required result when x is what? Less than 0. In this way we have got the value of what? Tan inverse of x in both the cases, when x is greater than 0 and when x is what? Less than 0. Similar type of result we are able to prove for what? This is the result related with what? Tan inverse of x is equal to cot inverse of 1 by x. Similar type of result we will get. Better way write down it as a note. So that cot inverse of x can be written as tan inverse of 1 by x. So this result also we are applying sometimes while solving the example. In this way we have proved 3 important properties. Now observe the property number 4th. In this property we have to prove that value of sine inverse of minus x will be equals to minus sine inverse of x. Means we are finding sine inverse of what? Negative value. In such cases we are able to apply this property. So let us try to prove this property. So here we are supposing that let y is equal to sine inverse of minus x. So now this value of sine inverse we have denoted by what? Y. It means y is the value of sine inverse. If y is the value of sine inverse, means it lies in its range set, means we can say that. So therefore y belongs to which interval? Minus pi by 2 to plus pi by 2. Okay, now let us simplify it and let us try to get our required result. So therefore we are taking sine on both sides. So on this side we will get sine y, and on this side sine and sine inverse will get cancelled. Remaining term is minus x. Simply I am multiplying both side by minus. If I am multiplying to left hand side by minus, on this side we will get minus sine y, and on this side we will get plus x. Now this minus sine y, can I write it as sine minus y? Yes, we know that sine minus theta is equal to what? Minus sine theta. So minus sine y can be written as what? Sine minus y. On this side x, keep it as it is. Now we are taking sine inverse on both sides. If we are taking sine inverse on left hand side, so on this side sine inverse and sine will get cancelled. What is remaining term? Minus y. And if we are taking sine inverse on this side, we will get sine inverse of x. So just simply we have taken here sine inverse on both sides. So on this side if we are taking sine inverse, remaining term is minus y, on this side we will get sine x. Now try to understand the very important part. Minus y is the value of what? Sine inverse of x. Minus y is the value of sine inverse of x, means it should belongs to its range set, and its range set is in which interval? Minus pi to plus pi. Now we have to check whether this value lies in between range or does not lies in between range. If it lies in the range of sine inverse, so we are able to consider it as what? Principal value. Otherwise we are not able to consider it as what? Principal value. Okay, so now here already what result we have got here? Y is greater than or equals to what? Minus pi by 2, and less than or equals to what? Plus pi by 2. Y lies in this interval, means y lies in between minus pi by 2 and plus pi by 2, including minus pi by 2 and plus pi by 2, since the interval is what? Closed interval. Now we will require the value of what? Minus y. To exist minus y here, we are multiplying by minus to each term. If I am multiplying here by minus, we know that in case of inequalities, if we are multiplying by minus, inequality will get changed. Just try to understand. Consider one example. We know that 5 is less than what? 10. If we are multiplying to both the term by minus, here we will get minus 5 and here we will get minus 10. Now which number is greater? So minus 5 is greater. Means inequality will get changed if we are multiplying by what? Minus. So here also inequality will get changed. If I am multiplying here by minus, minus pi by 2 will become plus pi by 2. Here also inequality will get changed, and here we will get minus pi by 2. Just simply we are multiplying by minus and we are using properties of inequalities. Now we can observe that minus y lies in between what? Minus pi by 2 and what? Plus pi by 2. And this is nothing but what? Range of which inverse trigonometric function? Sine. So we are able to consider this as an value of what? This as an value of which inverse trigonometric function? Sine inverse of x, because it lies in this principle, lies in the range of sine inverse. So we are able to consider it as an principal value. So now this can be written as, take minus on this side, so y will be equals to minus sine inverse of x. Just simply multiplying both sides by minus. On this side we will get plus y, on this side we will get minus sine inverse of x. Now y is nothing but what? Y is equal to sine inverse of minus x. Just replace this left hand side by its value. Y is nothing but what? Sine inverse of minus x. Keep right hand side as it is, minus sine inverse of x. And this is the result which we have to prove here. We have proved that sine inverse of minus x will be equals to minus sine inverse of x. Total 6 results are there. So we are going to prove all the properties using what? Same method. Now let us try to prove the property number 5. In this property we have to prove that the value of cos inverse of minus x is equal to pi minus cos inverse of x. Try to understand this result. So now here we are considering a left hand side, so we are denoting it by y. Y is equal to cos inverse of what? Minus x. Now taking cos on both sides, so what we'll get here? So therefore cos y is equal to, on this side remaining term is minus x, taking minus, just we have taken cos on both sides. So on this side we'll get cos y, and on this side cos inverse of minus x is minus x, means cos and cos inverse will get cancelled. Now multiplying both side by minus. So on this side we'll get minus cos y, on this side we'll get x. Just simply we are multiplying both side by minus. Now try to understand the next very important step. Can I say that minus cos y is the value of cos pi minus y? According to allied angle formula, we know that cos pi minus y is nothing but what? Minus cos y. So therefore, now if we are taking cos inverse on both sides, on this side cos inverse and cos will get cancelled, remaining term is what? Pi minus y, and on this side we will get cos inverse of x. Just simply we have taken cos inverse on both sides. Now here we can observe that pi minus y is the value of which inverse trigonometric function? Cos inverse. If it is the value of cos inverse, means we have to prove that it belongs to its range, and its range is which interval? 0 to pi. Now let us check whether this pi minus y belongs in that range or does not belongs to range set. What is the range set here? 0 to pi. Now here, according to our supposition, y is value of what? Cos inverse, means it implies that y belongs to which interval? 0 to pi. Okay, so y is nothing but value of cos inverse, means definitely it will lie in which interval? 0 to pi. Now this condition is available with us, using which we have to check whether pi minus y belongs to this interval 0 to pi or does not belongs to 0 to pi. Can I write this as y is greater than or equals to 0 and less than or equals to pi? Yes, y belongs to this closed interval, means y lies in between 0 to pi, including what? 0 also and pi also. Now observe this expression very carefully. Minus pi is there, so I am multiplying by minus, and we know that if we are multiplying by minus, inequality will get changed. So here we will get minus pi. Just simply this result we have got simply multiplying to all the terms by what? Minus pi, and minus. If we are multiplying by minus, inequality less than or equals to becomes what? Greater than or equals to. Here also less than or equals to will become greater than or equals to. So we have tried to exist what? Minus pi, but minus pi is not our requirement. Our requirement is what? Pi minus y. To get here pi minus y means we have to add pi. If we are adding pi in this term, means we have to add pi in all the terms. So let us add pi here. If we are adding pi, 0 plus pi will become what? Pi. And here if we are adding pi, so here we will get pi minus y, and if we are adding pi here, minus pi plus y will become 0. So what we have proved here, so this pi minus y belongs to which interval? 0 to pi. Belongs to which interval? 0 to pi. So we have proved that pi minus y belongs to 0 to pi, which is nothing but range of which inverse trigonometric function? Cos inverse. That's why we are able to consider this as an what? Principal value. So therefore this plus pi on this side will become minus pi. On this side remaining term is minus y is equal to plus pi on this side will become minus pi. Keep remaining term cos inverse of x, keep it as it is. Since, so therefore, and this implies, okay, so therefore now on this side to replace minus, I am multiplying both side by minus. So here we will get plus y. If I am multiplying here by minus, this negative term will become positive. If I am multiplying here by minus, this positive term will become negative. Now this y can be replaced by, y is nothing but what? Cos inverse of minus x. So replace this y by its value cos inverse of minus x. Don't disturb to right hand side, pi minus cos inverse of x. So in this way we have got the proof of next important property, that cos inverse of minus x is equal to pi minus cos inverse of x. Now let us try to prove the property number 6. In this case we are showing that value of tan inverse of minus x will be equals to minus tan inverse of x. So consider the left hand side. So we are denoting that value by y. Y is equal to what? Tan inverse of minus x. If y is the value of tan inverse, means it belongs to its range, means y belongs to what? So therefore y belongs to minus pi by 2 to plus pi by 2. Okay, because this is the value of tan inverse. Let us simplify it. Taking tan on both sides, on this side we will get tan y. If we are taking tan on this side, tan and tan inverse will get cancelled. Remaining term is minus x. Simply we are multiplying both sides by minus. So on this side we will get minus tan y, and on this side if we are multiplying by minus we will get plus x. So now minus tan y can be written as tan minus y. We know the trigonometric ratios or trigonometric functions of negative angle. Tan minus theta is equal to minus tan theta. So that's why minus tan y can be written as tan minus y. Don't disturb to this side, keep this side as it is. So now taking tan inverse on both sides. So on this side if we are taking tan inverse, tan and tan inverse will get cancelled. Remaining term is minus y, and on of x, just simply we are taking tan inverse on both sides. Now minus y is the value of tan inverse of x. If it is the value of tan inverse, means it should belongs to its range. Its range is in between what? Minus pi by 2 to plus pi by 2. Let us check whether this value belongs to range or does not belongs to range. We have to check that minus y belongs to what? Minus pi by 2 or plus pi by 2. In between minus pi by 2 to plus pi by 2. As it stands, y is greater than minus pi by 2 and less than plus pi by 2. It is given to us. It is open interval. That's why we can say that y takes the values in between minus pi by 2 and plus pi by 2. Now we will require what? Minus y. To exist minus y here, we are multiplying by minus to all the terms. If we are multiplying by minus, inequality will get changed, means less than will become what? Greater. Here multiply by minus, it will become plus pi by 2. Here we will get greater than, here we will get minus y, here less than will become greater than, plus pi by 2 will become what? Minus pi by 2, just simply multiplying by minus. Now this implies that minus y belongs to which interval? It lies in between what? Minus pi by 2 to plus pi by 2, minus pi by 2 to plus pi by 2. Means minus y belongs to range of tan inverse. That's why we are able to consider this as an value of what? This as an value of tan inverse of x. So now if we are multiplying both sides by minus, so what we'll get here? Y is equals to minus tan inverse of x. Just simply multiply both sides by minus. So therefore y, what is the value of y? Tan inverse of minus x, tan inverse of minus x. On this side keep minus tan inverse of x as it is. In this way we have proved that tan inverse of minus x is equals to what? Minus tan inverse of x. Now let us try to prove the next important property. In this way we have to show that value of cosec inverse of minus x will be equals to minus cosec inverse of x. So let us denote here cosec inverse of minus x by what? Y. Cosec inverse of minus x will be equals to y. Y is the value of cosec inverse, means it lies in between which interval? So therefore y belongs to minus pi by 2 to plus pi by 2, difference 0. Okay, so now simplify it. Now we are taking cosec on both sides. So on this side we will get cosec y, and if we are taking cosec on this side, cosec and cosec inverse will get cancelled. Remaining term on this side is minus x. So taking minus on this side, so minus cosec y is equals to x. Now minus cosec theta can be written as what? Cosec minus theta. We know that cosec minus y will be equals to minus cosec y. On this side x, keep it as it is. Now we are taking cosec inverse on both sides. If we are taking cosec inverse of left hand side, cosec and cosec inverse will get cancelled. Remaining term is minus y, and on this side if we are taking cosec inverse we will get cosec inverse of x. Just simply we have taken cosec inverse on both sides. Now minus y is nothing but value of what? Cosec inverse. If to consider minus y as a value of cosec inverse, we have to prove that minus y belongs to which interval? Minus y belongs to what? Minus pi by 2 to plus pi by 2. Now we are using our given condition here. Since y is greater than or equals to minus pi by 2 and less than or equals to what? Plus pi by 2, and y is not equals to what? 0. So therefore we will require what? Minus y. That's why we are multiplying to all the terms by minus. If I'm multiplying here by minus, minus pi by 2 will become plus pi by 2, less than or equals will become greater than or equal. Here minus y, again less than or equals to will become greater than or equals to, and here we will get minus pi by 2, and y is not equals to what? 0. Now we have proved that minus pi lies in which interval? Minus pi by 2 to what? Plus pi by 2. So this implies that minus y belongs to minus pi by 2 to plus pi by 2, and here difference what? 0. Y is not equals to 0. Now since minus y lies in this interval, so that's why it can be considered as principal value. So therefore this y, keep it as it is, taking minus on this side. So on this side we will get minus cosec inverse of x, and lastly replace this y by its value. What is the value of y? Cosec inverse of minus x, and on this side minus cosec inverse of x, keep it as it is. So this is the result which we have to prove. In this way we have got the proof of what? 7th important property. Now see the property number 8. In this property we have to prove that sec inverse of minus x is equal to pi minus sec inverse of x. So let us denote the left hand side by y. So let y is equals to sec inverse of minus x. So which implies that if y is the value of sec inverse, means it lies in this range. So that's why we can say that y belongs to 0 to pi, difference what? Pi by 2. Okay, so now let us simplify it. So we are taking sec on both sides, so on this side we will get sec y. If we are taking sec on this side, sec and sec inverse will get cancelled, remaining term is what? Minus x. Now I am multiplying both sides by minus, so on this side we will get minus sec y is equal to x. Now minus sec y according to allied angle formulas can be written as what? Sec pi minus y. We know that sec pi minus theta is equal to what? Minus sec theta. On this side x, keep it as it is. So therefore this expression can be written as pi minus x, keep it as it is. Now we are taking sec inverse on both sides. If we are taking sec inverse of left hand side, sec inverse and sec will get cancelled, remaining term is pi minus y. And if we are taking sec inverse of this side, on this side we will get sec inverse of x. So therefore here we can observe that pi minus y is the value of what? Sec inverse. If it is the value of sec inverse, then we have to prove that it lies in the range of sec inverse. And what is the range of sec inverse? 0 to pi, difference pi by 2. Let us check whether this value lies in that interval or not. Already we have shown that y lies in this interval 0 to pi. Now we have to check that pi minus y also lies in that interval or not, because this is the value of what? Sec inverse. Now we are using given condition. So since y is what? Greater than or equals to 0 and less than or equals to what? Pi, and y is not equals to pi by 2. So just this symbolical representation can be written in this form. So now here minus y is there. To get minus y, we are multiplying to all the terms by minus y. So therefore if we are multiplying by minus, so here we will get 0, less than or equal to become greater than or equals to, here we will get minus y. Here less than or equal to will become greater than or equal to, and here we will get minus pi. Just simply we are multiplying to all the terms by what? Minus. And here keep this term y is not equals to pi by 2 as it is. Now again what will require? Minus y we have got here. To get pi minus y, we have to add pi here. Means we have to add pi in all the terms. If we are adding pi here, 0 plus pi will become pi. Keep inequality as it is. Here we will get pi minus y. Here keep greater than or equals to as it is. And if we are adding pi here, minus pi plus pi will become 0. And y is not equals to what? Pi by 2. Keep it as it is. Now this implies that y belongs to what we have proved here. Y belongs to what? 0 to pi. Y lies in, sorry, not y, pi minus y. So this implies that pi minus y belongs to what? 0 to pi. Difference what? Difference pi by 2. Difference pi by 2. Okay, so now since pi minus y belongs to this interval, means belongs to the range of sec, that's why we are able to consider this as an value of what? Sec inverse. So now this plus pi on this side will become minus pi, on this side remaining term is minus y. Just simply using transformation, we are taking pi on this side, keep this term sec inverse of x as it is. Now to replace this minus, I am multiplying both side by minus. So here if I am multiplying by minus, we will get y. On this side if I am multiplying by minus, minus pi will become plus pi. Multiply by minus, plus will become minus, minus sec inverse of x. And lastly, replace this y by its value. What is the value of y? Y is equal to sec inverse of minus x. So sec inverse of minus x. On this side, pi minus sec inverse of x, keep it as it is, and this is the result which we have to prove. What we have to prove here? Value of sec inverse of minus x will be equals to pi minus sec inverse of x. Now let us try to prove the property number 9th. In this case, we have to prove that cot inverse of minus x is equal to pi minus cot inverse of x. So let us denote cot inverse of minus x by y. So let y is equal to cot inverse of minus x. Now y is the value of what? Cot inverse of minus x means it lies in which interval? 0 to pi, which implies that y belongs to which interval? 0 to pi. Now let us simplify it. We are taking cot on both sides. So on this side we will get cot y. On this side if we are taking cot, here cot inverse of minus x is there. If we are taking cot, so cot and cot inverse will get cancelled. Remaining term is minus x. Now I am multiplying both side by minus. So on this side we will get minus cot y, and on this side we will get x. Simply multiplying both side by what? Minus. Now minus cot theta according to allied angle formulas can be written as cot pi minus theta. Theta is what here? Y. So keep this side as it is. Just simply minus cot y can be written as cot pi minus y. Now taking cot inverse on this side. If we are taking cot inverse on this side, cot and cot inverse will get cancelled. Remaining term is pi minus y. And on this side if we are taking cot inverse, we will get cot inverse of x. Now what is the value of cot inverse of x? Pi minus y. Now if it is the value of cot inverse, means we have to prove that it lies in range. And what is the range of cot? 0 to pi. Range of cot inverse is what? 0 to pi. So already what result we have got here? Since y lies in between what? 0 to pi. It lies in between 0 to pi. This can be written in this form also. Now here we will require minus y, so we are multiplying to all the terms by minus. So 0 into minus is 0, less than will become greater than, here we will get minus pi. Again this inequality will get changed, here we will get minus pi. Just simply we are multiplying to all the terms by minus, because here minus y is there. Again we have to add what? Pi here. So if we are adding pi, so here we will get pi, here we will get pi minus y, and if we are adding pi here, minus pi plus pi will become 0. So this implies that pi minus y lies in which interval? Pi minus y belongs to what? 0 to pi. And 0 to pi is nothing but what? Range of what? Cot inverse. Isn't it? So we have proved that this is the value of what? This is the value which lies in between 0 to pi, means we are able to consider it as a value of cot inverse. So now simplified, minus y, keep it as it is equals to this plus pi. On this side will become minus pi. Keep this cot inverse of x as it is. Now we are multiplying both side by minus. So minus y will become plus y. On this side if you are multiplying by minus, minus pi will become plus pi, and plus cot inverse will become minus cot inverse of x. So therefore y can be replaced by cot inverse of minus x. On this side pi minus cot inverse of x, keep it as it is, and this is the result which we have to prove here. In this way, in this property, and all these properties we are finding values of what? Inverse trigonometric functions of what? Negative angle, negative values. Means these formulas can be applicable if here the number is what? Negative. So in this way we have proved first 9 properties. In the next video we will prove the remaining properties. Total 15 properties are there in this chapter. So we have completed how many properties? 9 properties. Remaining part we will discuss in the next video.